right? So now, question for you: anti-clockwise, is it on top or below of the Mohr circle? Below. Are we clear? Now we look at point Y now. Okay, I'm highlighting in blue. Now point Y, based on the Y or the yellow that I highlight in blue, can you see blue or no? I'm colorblind. I see shit. I can't see anything at all. Okay, I see nothing. Okay, you can see color, yeah? There is color, yeah? I see nothing. Okay, that's why I cannot become a fighter pilot. On the radar, the red is enemy, the blue is good. I will shoot at anything. Okay, I cannot become a fighter pilot. So you can see now the element will rotate clockwise or anti-clockwise. So clockwise is on top or below? So this is your Mohr circle now. Come on. Today the computer is not behaving. You see, it's ridiculous. After I draw so many times, then it appears. Can you see that? So what does this mean? Positive shear and negative shear does not relate anything to what? Positive shear or positive magnitude of the element or positive at the Mohr circle or the negative on what? Mohr circle, right? We call this what? Positive shear. But when we plot, we have positive and negative what? Shear. Are we clear? It all depends on the rotation of the what? Element. Nothing to do whether is it positive shear or what? Negative shear. Okay, so let's do this another time. Okay. No, what I'm saying is where the X and Y point is on Mohr circle has nothing to do with positive or negative shear. Whether the position of X and point Y is dependent on the rotation of the element. Okay, it all depends on the rotation of the element. Let's do the one below. This is our point X, and this is our point Y. Okay, let's do this again. So if we do that, this is our stress, normal stress, and this is our shearing stress. Element rotate clockwise, element rotate anti-clockwise. So if we now look at point X, right, this will tend to rotate the element in where? Clockwise direction. So now this is our point X. And then if we look at over here, Y, this arrow over here will rotate the element in the anti-clockwise direction. Yes or no? So this is your point Y. And then now we can draw a circle. Okay. So the position of point X and point Y, okay, on Mohr circle is dependent on the element rotation. I did not know that as an undergrad. My prof did not tell me. My prof says does not matter. He's partially right and fully wrong. It does matter. I did not know that until I was doing my research. Okay.
What a bad prof.
Hey?
I said, what a bad prof.
Yeah, he said it does not matter. Because he did not know. I know. That's why I know when I was 45. I want you to know when you are 20. Okay? Yes. The top always has to be clockwise. The bottom is always has to be anti-clockwise. Okay? It's like in the beginning, 0 is the center, 1 is towards your right, -1 is towards your left. It's a notation. Okay? It's how we are going to relate from Mohr circle to the real world. We have to follow that notation. Okay? In that sense, we have to think like communists. Either you could do this way or I put you in jail, yes or no? Okay, if I go back to Singapore, I'll go back to jail. Okay, I'm that bad. Okay, so now we are going to do an example. Okay, we're going to do an example. So the example we're going to do, I like to pick example that are everything and anything. Okay, is this example over here? Okay, so this is our example number 1. Okay. I also include the solution, the solution from the manual, but it's just a check for me. Okay. So this is our example number 1. Okay. So I'm going to draw out what we are going to do first. Okay. There's a lot of component in this. So we have an element over here is 60, and then we have 90, and then the shear we have 30, all in megapascal. Okay. So the first thing we are going to do, this is our transformation. X and Y. First thing we're going to do, we are going to determine our average stress. We are going to determine our maximum shear stress. Okay. We are going to find our stress 1 and 2, okay, which is our principal stress. Then we are going to find our theta P, which is our principal plane. And then we are going to construct the principal. We are going to construct the element oriented to its principal plane. Okay. So we're going to do a lot of things. We're going to do 1, 2, 3, 4, 5 different things. Okay, which are very important in Mohr circle. Okay. Then later part, then we are going to rotate the element 25 degrees clockwise and 10 degrees counterclockwise. Okay, that is the later part. Okay. Yes. So on X, the element rotate clockwise or anti-clockwise? So at Y, it's going to rotate which direction? Yeah. You take this side also the same. Clockwise also. You take bottom, also the same. Anti-clockwise. Right? The same. Okay. Okay, so we're going to deal with this problem now. Okay. So we're going to construct Mohr circle. I'm going to copy this element. Okay. So we're going to draw Mohr circle. So on Mohr circle, now we have magnitude. Okay, so this is our normal stress. So I'm going to start from maybe minus 120. Okay, 100, 80, 60, 40, 20, 0, 20, 40, 60, 80, and 100. Okay. I don't know whether it's enough or not. I don't know. Okay. If not enough, then we draw some more. This is our shear. 20, 40, 60, 80. Shear stress, element rotate clockwise, minus 20, minus 40, minus 60, minus 80. Element rotate anti-clockwise. Make sure the scale that you use on the X and on the Y are the what? Are the same. Can you see the blue line, yes or no? You can see the blue line. I see shit again, okay? I'm really colorblind, okay? You can see the blue line, right? You can see, right? Oh my gosh. I see like white screen, you know? Okay. That's why during high school, when they asked me to do chemistry, and you know chemistry, you mix things, right? What is the color of the of the solution? I always get that question wrong, you know. I can't see it all. Sometimes I feel like drinking it, you know, but I can't, right? Always minus mark. Okay, that's why I got pissed off. I don't want to do chemistry, you know. I also cannot do electrical engineering. Okay, all the cables I cannot see the color well at all. The only time I do my own wiring, I will touch two cable, I can get electrocuted. Okay, it's alive, you know. Okay, so once you are ready, so we know that one stress state. So we are going to label this our point X, and we're going to label this our point Y. Okay, one is point X, one is point Y. Okay, then we are going to draw our normal stress line. So one is at minus 60. And one is positive 90. Ooh, I think I got this wrong. Yeah, I got this wrong. It's okay. Positive 90. Okay. So I'm going to add more 120 over here. Okay. I think I need to add